This is How the Sun Produces Heat and Light by Jacob A. Patterson. This is for Physics 2020 for Professor Essos. Introduction. Today I am going to talk about the life-bringing and yet destructive power of our star we call the Sun. It has been around for 4.6 billion years and will be here for another 5 billion years. This yellow G2 dwarf star is very small compared to other stars in the universe. But to us, it is the biggest mass in our universe. The Sun's diameter is about 1,392,684 kilometers in diameter. For a comparison, the Sun, there can be about 333,060 Earths that will fit inside of the Sun. The surface temperature is about 5,500 degrees Celsius and is about 15 million Celsius degrees at the core. The mass of the Sun is about 1.99 times 10 to the 30th kilograms. The Sun's mass is mostly a gas, but since the Sun is so hot that the gas is transformed into the fifth element, plasma, it is about 90% hydrogen and 9% helium. The rest is a combination of other elements such as silicon, iron, and etc. The Sun has many layers, just like the Earth, and there are 3 inner layers and 3 outer layers in the atmosphere and the surface. I will begin by talking about the innermost layer of the Sun and to the outermost layer. The center of the Sun is called the core. This is where all of the energy is made that is radiated to Earth and to the form of light and heat. The temperature in the core is about 15 million degrees Celsius. The density of the core is about 150 grams per centimeters cubed. Now we all know how dense gold is and how heavy it is, but the core of the Sun is about 10 times that of gold. And the Sun is about 20% of the entire Sun's mass of the Sun. The core is where all of the energy and the nuclear fusion takes place. The Sun's core generates about 385 billion watts of power. Like I said in the last slide, the core of the Sun is where nuclear fusion occurs. Now, a lot of people get nuclear fusion and nuclear fission swapped, but one good way to remember is fusion is the combining of nuclei to make atoms, and fission is the separating of atoms. The nuclear fusion that occurs in the Sun is when 2 hydrogen atoms come together to form 1 helium atom. And the mass that is left over from this reaction is then transformed into energy. This process is the same as hydrogen bombs. The next layer after the core is the radiative layer. This layer is about 60% of the sun's mass. The temperature of the radiative layer is about 7 million degrees. Now the electromagnetic radiation is taken from the core. It takes about 1,700,000 years for the light energy to make it through this layer and turn into light photons. Now if you think about it like this, the light that we are receiving right now was made back when the dinosaurs walked the earth. It's pretty interesting. Now, to make it through this layer and turn into photons, the density of this layer is about 20 grams per cubic centimeter squared. It's cubed, sorry. Like most of the sun, this layer is a gas filled with other helium and atoms and hydrogen atoms. The next layer is called the convection zone. The convection zone and the radiative layer are separated by a thin boundary called the tachocline. This zone reaches a depth of about 200,000 kilometers in depth. This is a smaller portion of most of the sun. The energy that is within this zone moves very differently. It's kind of like boiling water. That energy swirls around inside the zone in the formation called a convection zone. I'm sorry, it's called a convection cell. The energy swirls around, collecting more and more energy until it finally leaves the top layer of the convection zone. It is connected to the part of the photosphere. Next, we have the outer layers of the sun. The photosphere is the surface of the sun. It is also the thinnest layer of the sun. This layer is only about 100 kilometers thick. In this layer, we can see sunspots appear. The temperature of this layer is about 5,500 degrees Celsius, and the sunspots are the cool spots and the dark spots of the sun. And this is where the sun's energy is released. The spots can reach a very huge diameter of about 50,000 kilometers. This layer is where the light is emitted. It takes light to travel to Earth from the sun about 8 minutes, traveling at, of course, the speed of light. So, to think about it, if the sun went out right now, then we would still have about 8 minutes of good sunlight until the world went completely dark. The next layer is called the chromosphere, also known as the color sphere. This layer emits a reddish color, also known as alpha wave emissions. You are only able to see this layer during solar eclipses. Because of how bright the center of the sun is, you would not be able to distinguish where the chromosphere is and the surface of the sun is. The temperature of this layer is about 4,000 degrees, which is one of the coolest layers. Also, you can also see sunspots visible in this layer. And the final outermost layer is called the corona, Also, this layer can only be seen during a solar eclipse. This is the most interesting of layers in the sun because it is extremely hotter than the surface of the sun. Since usually heat energy dissipates the further it moves from the source, but the temperature goes from 4,000 degrees at the surface to roughly 2 million degrees Celsius in the corona. This has baffled scientists for very many years. They have a theory that it may be because of the storms and solar explosions happening at the surface and shooting all kinds of heat and energy into the corona. But of course, this is just a theory. Next, I will talk about solar power and energy. At about midday, almost every point of the world has about 900 watts of solar energy available for use. The solar cells that are used in solar panels capture electric wavelengths of radiation and convert that energy into electricity. We can use solar energy to power certain parts of our home or simple electric powered machinery like air conditioners and water heaters. We can put these solar panels on top of our houses or even make roads and sidewalks that collect the solar energy and power the street lights. There are many pros and cons of using solar power. Some of the pros would be, of course, that it's free. Since nobody owns the sun, we can freely collect as much energy as we please, and it is unlimited. For billions of years, there will always be solar power to use. And solar powered panels are silent and are completely safe to use. Also, the maintenance required is very little. But, of course, there are some cons, and some of them would include that solar panels are very expensive to make, and that the amount of energy depends on the weather, of course. So if there's a cloudy day, then you will get some energy, but it will not be nearly as much as when it's a sunny day. And of course, you can't collect any of the at night. Also, the materials that are used to make the solar panels are hazardous, and the storage containers used are also very, very expensive. And this is some of the works cited that I did.